All right, so today is a real important property, and it's one that's going to come up very often, regularly, almost daily in algebra and above. Now, we're still in pre-algebra, and we're still dealing a lot with just numbers. You know, we have yet to go the big fraction chapter where we've got to make sure we're good in adding, subtracting, multiplying, dividing fractions, and that's still coming. And that's all just pure numbers. Um, but soon we'll get to variables, the letters, and they'll be in everything, and that's what algebra is. Variables, letters are involved in everything. And when they are, the distributive property is very important. Very important. So its full name is really the distributive property of multiplication over addition. So the full name of the property is the distributive property of multiplication over addition. But we usually just say the distributive property for short. Now, why the full name? If you look at the blue box, this A is doing what to the parentheses? What's the operation? Say it if you know it. Multiplication, right? So there's the multiplication. What's happening inside the parentheses? Things are being added. So hence the big full name, the distributive property of multiplication over addition. But again, we normally just say the distributive property. All right, does it work? First off, I want to get you to understand, does it work? Well, let's write it. Here's how it goes. Take your color inside the blue box. You're supposed to multiply your A, and take your red here and draw an arrow from the A to the B. So use a raised dot, and then take your green and draw the B. You're supposed to multiply the A times the B. Take your blue plus sign. Take your red again and draw another arrow from the A, this time to the C. And you're supposed to multiply the A times the C. We distributed the multiplication. So let me give you time to write that and let that sink in. By the way, anybody besides Christina not have their notes today? Okay, good. So you got A times B plus A times C, the distributive property. Now, to be quite honest with you, with numbers, we just simply apply the order of operations and deal with numbers. So that's what I want to do here on the left-hand side. If we were doing this problem, normally we would apply the order of operations. We all know a 3 and a 4 is a 7. So do you agree the left is a 2 times a 7? And if we finish the left-hand side, 2 times 7 is 14. All right, so that's our value. Now let's see what happens if we use the distributive property. We better get a 14. So now I'm working on the right-hand side, right? 2 times 3, we all know, is a 6. We got plus 2 times 4, we all know, is an 8. And sure enough, 6 and 8 is 14. And sure enough, the property worked. Now let me again try to state, we really don't use it for numbers. I'm just using numbers to show it works. They're going to give you a few numbers because we're trying to teach you the property. But it's really for when there are variables, and I'll show you that in a little bit. The point is the property works. It does get us around the order of operations, but that's okay. It does work. The point is you have to distribute the multiplication to everything in the parentheses. So I don't like doing it with just numbers, so you can see our examples here have variables. So let's see how it works. Now, we could write it out, and we could show each step, but to be quite honest with you, I found students get it better if we just simply do the distributing, the multiplying. So stay with me. Please ask questions if you don't get what we're doing. So I'm going to take this 4, I'm going to circle it in red. And the first thing I want to do is multiply it times the 2x. So somebody raise your hand and tell me, what do you get when you multiply 4 times 2x? Brendan? You do get 8x. And hopefully you agree with that. And now I need to multiply the 4 again times the positive 3. And we can all do that. Everybody knows 4 times positive 3 is. But look, here's what some students do. Can I just write the number 12? I need to have that plus sign because it's a placeholder. So a 4 times a 2x plus 3 ends up being an 8x plus 12. And that's as far as we can go with that problem. We can't do anything more. We have simplified it from where it was, but we can do no more. We can't add an 8x and a 12. They don't add. It would be like this. What are 8 cupcakes and 12 marbles? 8 cupcakes and 12 marbles. They don't add up. You know, what's $8 and 12 raisins? $8 and 12 raisins. You can't add them. They're not like terms. We're going to talk about that in a couple days. That's as far as you can go. That's your final answer. You've distributed. You've done the distributive property. So the second example is similar. You know, I've got what we're distributing in red. So it's going to be a 5 times a 3n. So what do you get when you multiply a 5 times a 3n? Hayden? It is a 15n. And if you look, all we have left is a 5 times a 1, and that's a positive 5. And that one's done. We've done the distributive property. 15n plus 5. All right, so that's in its purest form, and that's pretty simplistic. Everything's positive. But as you know, pre-algebra, we start dealing with positive and negative numbers, right? So now we got to make sure that we're good to go with the positive and negative numbers. So look at C. Remember, I'm trying to teach you to keep the sign with the number. So this is a negative 2 that we're distributing. So what do we get on the first distribution? Allison? Negative 8y, right? Because negative 2 times 4 is negative 8 times the y, negative 8y. Somebody raise your hand and tell me, what do we get on the second distribution? Hannah? How many agree with Hannah, negative 10? You'd be all the correct ones, right? A negative 2 times a positive 5 is a negative 10. So this is a negative 8y minus 10. All right, now, question, Luke?
Is that the answer?
That's as far as we can go. This, the distributive property, Luke, is a means towards an end. So it's so we can do something so that hopefully later on we can go even further. Right now we're just trying to learn the property, so it's as far as we can go. Later on, it's going to be used in equations to be able to solve the whole equation. But right now, it's just, that's it. We can't go any further. We're learning how to use the property right now. Good question. So follow up, Luke?
So it wouldn't be like 18y?
Nope, because you can't add them up. Again, the point is there are negative 8 y's and negative 10 numbers. And y's and numbers don't add. Because the negative 8 tells you how many of them there are. And those are y's. Don't ask me why. It's just because. Did you catch that? All right, good. So it's called unlike terms. You can't add them. Hannah.
So if they're negative,
If they're negative, you just do what?
don't do anything.
Well, I did. I multiplied the negative 2 times the positive 5. Right? And a negative times a positive is a negative, and that's why it was a negative sign, because I did multiply that negative 2 times that positive 5. All right, so now I've got another example for you, D, and I'm going to want you guys to do it. Now, look, I know it's impossible. Math's hard, and we never practice anything more than 2 things, so you have no earthly idea what to do, and this is impossible. But Just give it a shot. See if you can do D. But I know you can't, but see what you can do. All right? I know I didn't deal with that. We have never seen anything like that before. How could we ever possibly get it right? But just see what you can do. And I'm going to pause the video. Okay, so hopefully, go ahead, Christian. What do you got?
You multiply the 3 by 3, so the negative 9x. And you multiply negative 3 by the 2y, which would be negative 6y, and then negative 3 by 4, which is negative 12.
So negative 9x minus 6y minus 12. How many have that? Oh, I thought it was impossible. Yeah, it's easy. It's math, right? Things you learn, you apply in similar situations. And that's exactly it. Distribute the negative 3 times the 3x, negative 9x, negative 3 times a positive 2y, negative 6y, negative 3 times a positive 4, negative 12. Colby. Again, so let's think back to where we were. Colby. So let's think back to where we were. So this is how we start our math. Everybody look up here in this box. So we start our math with something like this. 5 plus a negative 7. And I said to you guys, hey, you're not going to see it like that. We're going to write this problem like this because we don't need this extra plus minus in parentheses because it's exactly the same thing. A 5 plus a negative 7 is just like 5 minus 7. 5 positives and 7 negatives. And we don't write all the extra stuff. And it's the exact same thing here. You're not going to write plus a negative 6y plus a negative 12 because it means exactly that. And we write it in that form. Did that answer your question? Was that kind of what you were after? So no, you don't need those plus signs there. However, Colby, here we had to have a plus sign because it's the 8x plus the 12. Just like this is the 9x, negative 9x plus the negative 6y and plus the negative 12, but we don't need the extra plus signs because we know it means that. I don't know if that helped, but that's the idea. Christina. You shouldn't have the extra because it's my job as a teacher to teach you how to be excellent. And the person that's excellent won't add the extra stuff, though it's the same thing. Just like if I said, a variable for n, do we usually write the 1 in front of the n? We don't, though that's true. It is 1n. We usually just write n because, again, the person that's excellent understands that an n is a 1n. So I'm trying to teach you guys to write them the way that cares for them and the most simplified manner. So that's the idea, to do it in the most simplified manner. Okay, so let's look at 7a. Somebody explain to me how to do 7a. Chloe? Okay. And so do I have put a plus between like that? Everybody good with that? Whoa, we have dissent? Okay, how many's good with that? Just want to check. Only a few? How many don't like it? Whoa, all right. What's the problem? What do you want? Who wants to tell me what you want? What do you want? Christina, what do you want? What do you want it to be? So you want 14n minus 21 like that? How many are with Christina? Whoa, the overwhelming majority? So which one is it? 14n plus 21, 14n minus 21. Well, let me explain to you the principle I've already tried to teach you. Keep the sign with the number, right? So in the first one, 7 times 2n is definitely 14n. What's a positive 7 times a negative 3? It is a negative 21, and that's 14n minus 21. Because it is a 7 times a negative 3. All right, somebody do B for me. Somebody do B for me. Amber, go ahead. So she says 10 minus 20x. Anybody agree with that distribution? You should. That one's correct. Can we do 10 minus 20 as a negative 10 and get negative 10x? And the answer is no, because there's 10 numbers and negative 20 x's. Okay? It's like 10 peaches and negative 20 dominoes. Can't add them. They're not like terms. Christina? Nope, I want everybody to do the next one. All right, see what you can do on C. I'm predicting 5 of you are going to miss it. I hope I'm wrong. Prove me wrong. Go ahead and prove me wrong. Try C. I'm going to pause the video for just a moment now. Let's see. Hopefully, first off, you said negative 10y, right? How many are good to go so far? All right, perfect. But it's always that back number that I get concerned about. And do you have plus 6? How many have it correct? And about 5 of it. Let me see how many had it wrong. I want to count now. I'm curious. 1, 2, 3, 4, 5, 6. All right, I was saying 5. It was 7 of you. Does it make sense now that you see me do it? Right? A negative 2 times a 5y is a negative 10y. A negative 2 times a negative 3 is a positive 6. Keep the sign with the number and you'll be okay. Negative times a negative is a positive. That's why I picked that one to help you with it. All right. Questions on that one before I go on to D? Christina.
So, I got it right, but so negative 2 times negative 3 is 6, so you do a plus.
It's a positive 6, though. Just think of it, is it positive or negative? It's positive. You got to keep the sign with it. Whenever you distribute, positive numbers have to have that plus sign with them. It becomes a placeholder. Okay? Now, if you look at D, the distributing's kind of backwards, isn't it? The parentheses in the front and the numbers in the back. What are we going to do with that? Anybody have an idea? Somebody raise their hand. Any ideas? Emily, what do you want to do with that? Okay, so you want to multiply 3 times 9x and get what? Okay, is that it? We done? What else do you want to do?
And then you could do 3 times 5 and that's 15 and then you add the plus.
Okay, so here's what Emily just said to do. She kind of did it backwards, right? She did 3 times 9x. That's exactly what she said, right? And got 27x. And then she did 3 times a positive 5 is a positive 15. And you know what? That works. Matter of fact, when I distribute like that, that's the way I do them. Now, stay with me. You guys have a little bit of room on the bottom of your paper? I want to rewrite the original again. Use your color. And I want to show you another way. And then I'm going to show you a third way. There's 3 ways to skin this cat. And I'm a dog lover, so I love skinning the cats. All right, here we go. So here's way number. So this is, Emily did way number 1. I'm going to show you way number 2. You can actually distribute out of the parentheses. So take your green. What's a 9x times a 3? 27x, right? What's a positive 5 times a 3? Positive 15. There's a second way of doing that problem. I distributed out of the parentheses to what's multiplied times parentheses. Most students don't like that way. That's a little bit more abstract. There's a third way to do this problem, and it involves a property. Anybody come up with a third way to do this problem involving a property? Nia, was that your hand? Luke? Not quite the 3 and the 9x. You're close, though. You're close. Colby? Not the 3 and the 5. That won't work. Not the 3 and the 5. Chloe? See, the 3 is one thing, and the 9x plus 5 is really the second thing. It's a group. It's one thing grouped together. So we can use the commutative property. And most students like to distribute from the front. They feel more comfortable. Now it looks like every other problem we've done. So Emily, she's good at back distributing. She did that well. I like to just distribute right out of the parentheses, but most students don't like that. But hey, distributive or commutative property, now it's 3 times 9x, 27x, 3 times 5, 15. And sure enough, in all 3 methods, we get the correct answer, don't we? So I don't care which way you skin the cat, just skin him the right way. All right? Christina.
So you could do that any
You could. You could. But it's usually when what you're distributing is in the back. All right, a few more problems for practice. So I want everybody to try A and pause, and then we'll go on. I'm going to pause the tape. Go ahead and do A. Uh-oh, you're in trouble. Commutative property says you can change the...
order.
If you don't know that, come tomorrow. You're going to be in trouble. Associative property says you can change the grouping. If you don't know that, you're in trouble for tomorrow. Identity gets you back to the original. You got to know that. Inverse, for addition, you add inverses. For multiplication, you multiply reciprocals. Make sure you know your properties. That's tomorrow's quiz. Okay, so hopefully you said 5 times 3x is a 15x. 5 times a negative 4y is a negative 20y. 5 times a positive 2 is a positive 10. How many got that right? Okay, good. Great job. Awesomely awesome. B has a pitfall. B has a pitfall. Do you guys want to try it?
Yes.
All right, try it. Okay, are you ready? Here's the pitfall. A lot of students will say 10 minus 3 is 7. Why can I not do that? Why can I not do that? Allison? Kind of, sort of. The reality is, distributing is what thing? What operation is distributing? We are multiplying. You got to multiply before you add. So on this one, whoa, you have to leave that 10. It's just sitting there. And you got to distribute your negative 3. Negative 3 times 2x, negative 6x. Negative 3 times a negative 5, positive 15. Now, the last thing we can do is we can add the numbers up. A 10 and a 15 is a 25. We still have the negative 6x. That one ends up negative 6x plus 25. Now, I wouldn't expect hardly anybody to get that correct. Did anybody, perchance, get it correct?
I got the answer right. I did the same wrong.
Well, if you did it wrong, then you shouldn't have gotten it right. So you probably made 2 mistakes. So that's the reality. You've got to distribute first. You cannot add the 10 and the negative 3. You can't do that. You're violating the order of operations. Otherwise, you end up at 14x minus 35, and that's not the answer. It is a negative 6x plus 25. All right, last one. This one is easier. Go ahead and solve that last one. Pretty confident you guys will all get this correct. Do C. Colby, what do you got?
Negative 15a plus 6b plus 12.
And hopefully that's what everybody got, right? Because that's the correct answer. Negative 15a plus 6b plus 12. Distributing is not hard. You just got to take it one step at a time, and away you go. All right.